Hi everyone, welcome back to Tech Classes. This is the fourth video in this series and topic is input output interfacing. Now let us come to the agenda for discussion. First we will classify all the associated embedded devices. Then I'll explain how to define a pin as input or output. Then we'll discuss about input output reading and writing. Then finally we will do a IO interfacing project. Now come to IO devices classification. All the devices associated with embedded system can be categorized into two types: input device or output device. All switches like SP, ST, SPDT, DPDT, push button, all are coming under input devices. Similarly, all sensors like IR, ultrasonic, temperature, pressure, humidity, all are coming under input device. And in the output devices, all bulbs like LED, then AC/DC bulbs, all display like LCD are coming under output device. Similarly, all types of motors, DC, AC, stepper, servo motor, all are falling under output devices. Similarly, relays, contactors, solenoid are also coming under output devices. Now let us do a IO interfacing project using Proteus and Arduino IDE. Now this one is Arduino IDE and this is Proteus environment. And here what first I will do is, and this is the schematic capture window. Now here first I will go to the component mode and I will take Arduino here, and from the top third one, this one is the Arduino UNO R3, so I will select that one, and I will take one input device, that is your push button, so I will just type push. Then here this is the top on the list, push button, this is the symbol, and I will take this one, double click to select it. So this one is selected. Now I will take one LED, yellow LED, so I will double click to select it. Similarly, I will take a series register to protect it, the 220R. Then register, then 0.6, so this is the component. Then I will take another register 10K, so this one. So this is my component requirement. Now I will take Arduino. This is the preview. I will rotate it to bring this USB side upside. Now I will place this component here and adjust the window. These are the digital pins I will use here. Then first I will interface the LED. So I will take the LED here, this one, I will rotate it. Then I will connect this to pin number 13. Now I will take ground terminal from here, then I will place it right here. Then I will establish the connection. To protect this LED from high voltage, I will take the series register. This is the register 220 ohm, and I will just connect this here. So now this is the schematic to interface LED with Arduino UNO. This LED we are going to connect to pin number 13. Since LED is the output device, so pin number 13 should be declared as output in the program. So let us declare pin number 13 output. So this is Proteus, in this is Arduino. Here I will define this pin as output, and to define the pin I will call the function pin mode, and here I'll write pin number 13. This is the pin I want to declare, and I will declare it as output and semicolon. So here this is the pin I have declared it output. Then I want the cell to be on, so that's why what I have to do is I have to drive pin number 13 to high, so that this LED will be forward biased and it will on. So to generate output from the pin, I will call digital write function, and here same way which pin you want to drive, pin number 13, and I want this pin to drive high, so that's why I will write high. If you write low here, then it will drive low, that means output from the pin will be low. Now this is the code. In the first syntax I have just defined pin 13 as output, and in the second I am driving this pin to high. Let us compile it. Compilation is done. Now I will export the binary file. Now to see where my binary file is located, just I will click here, so sketch folder. This is the project name is IO interfacing, and this is inside the document. Now I'll just double click on this Arduino UNO, and here I'll browse and go to document, then Arduino, then inside this IO interfacing, this is the project. Then here out of this 2 hex file, anyone I'll link. So first one I am linking, then click OK and run simulation. Now see this LED is glowing because the last line I have written to drive pin number 13 high, that's why output from this pin is high, that's why LED is glowing. Let us take a probe, voltage probe, and connect to the pin number 13, so that how much voltage is generated from the pin number 13 will be seen. Again I am just running simulation. See output from this pin is 4.7 volt, so that's why this LED is on. Now let us slightly modify the program here. I want this L to be on for 2 seconds, so that's why I will apply delay. This is the function to introduce delay in my program. So I want 2-second delay, so that's why I'll write 2000, because this function takes delay in millisecond, so that's why 2000 millisecond equal to 2 seconds, so 2-second delay. Then I want this to be up, so that's why I will copy this line, then paste, and I want this cell to be up after 2 seconds, so I will write here low. Now again I will export the compile binary, then I will run simulation. Now see this LED is glowing for 2 seconds. After 2 seconds it will off. It is off because output from this pin is 0. So this is the way how digital pen works. First you have to define the digital pen as output by pin mode function. Then you have to drive the digital pin by digital write function. If you write high, then output will be high, and if you write low, then output will be low. Now let us interface this push button switch. So this is the push button switch. I'll take it and I will connect it to pin number 2 here, to any digital pin you can connect. Then I will take ground, then I will connect one end of the switch to ground. Then I will establish the connection here. See, one end of the switch is connected to pin number 2 and other end is grounded. Now this switch is at off state, and when it will be on state, pin number 2 will be connected to ground. But when this switch will be at off state, see, since this is digital pin, pin number 2 should be at VCC or at high. But here, by just connecting a switch, it is not happening. That's why what I will do, uh, I will take a register and I will use this ratio pull up register. I will connect this register here. Then I will take power. Then I will complete the connection. Now see, where I am using this register as pull up register. So now what will happen here? Now see, the switch is off and pin number 2 is connected to the VCC through 10K. So this pin number 2 will be at high now. But as soon as this switch will be closed or at on state, what will happen? Now pin number 2 will be at 0 volt. Since this is high resistance path, so pin number 2 will be not connected to VCC. Now it will be connected to ground. So this is the way how you can differentiate the on and off state of the switch. When switch will be on, then voltage at pin number 2 will be 0, but when it will be released, voltage at pin number 2 will be VCC. Now let us write program. So remember, our switch is connected to pin number 2 and switch is an input device. That's why you have to define pin number 2 as input first. So what I will do here, I will copy this line, pin mode, then enter here and paste here, and I will define pin number 2 to which LED in switch is connected as input. So here I will type input. So here I have defined pin number 2 as input because push button switch is connected. Then what we want here, now when switch will be on, I want this LED to be on, and when switch will be off, I want LED to be off. Now question is, how does this microcontroller know that whether this switch is pressed or not pressed, or it is on or it is at off state? Now what you have to do in our programming is that just you have to read pin number 2. If red value is high, then switch is on, off, so you have to keep this LED at off state, and when this red value of this pin will be low, that means this switch will be closed, so you have to drive this pin high. So to read this pin, what you have to do is, first you have to define a variable here in the program. So I will take a variable int type, because here state of this switch will be 0 or 1, so that's why int. Then let variable name is pin state, this is the variable, and I will read the pin. To read pin, there is a function digital read, this is the function, and it has only one argument, which pin you will be reading. You have to just type the number of that pin. So here I am reading pin number 2, that's why I just written 2 here. So that means here when this line will be processed, what will happen? Now pin number 2 will be read, and that read value will be stored in pin state variable. So this is the way you have to read a pin. If you want to read other pin, then you have to write the number of that pin. Now what I will do, I will write conditional statement. If pin state, this is the variable where pin state value will be stored after reading. So that's why pin state, if it is equal to, if that red value is equal to low, that means switch is on, low. Then what I want, I want to this LED to be on, that's why I will write the syntax to make that LED on, and to on that LED already code is written, so I will just copy that syntax from here and I will paste here. So now what will happen, if state of the pin number 2 will be low, that means switch is pressed, which will be pressed, then LED will be drive high, so LED on. Then just I will copy this, then I will paste here, and here else, if switch will be at off state, else that means if switch will be at off state, then what will happen, now I want this LED to be off, so I will type off, and to off this I will drive pin number 13 low. So this is the program. First you have to read the pin and you have to store the read value in a variable. After that you have to compare if pin state will be equal to low, that means switch is pressed, then you have to drive the output high so that LED will on, else means switch at only two state, if it is on low, else it will be off, so that's why else what is, now you have to drive that pin low so that LED will be off. So this is the program, and here I will just delete this part here. Now I will go to sketch and export binary. Then I will run simulation here. Now see, switch is off, LED is off. Now I will just close this switch, LED on, off, on, off, on. So this is the program. Okay. Now see, this is the pull-up register I have used here. This is a physical register, extra component we are using. You can also replace this component by a syntax in the program, that is known as your pull-up programming. So let us delete this component from here and we will replace this component by a syntax. First, see here pin is 2. So first here you have defined pin number 2 as input, and here just I will call a function digital write which pin number 2, and I will drive this pin high. This is known as pull-up programming. Pull-up. First what you have to do, now first you have to define the pin as input. After that you have to drive that pin high. So this is a input pin. You cannot generate output from an input pin. But here what will happen? Instead of generating output, this pin number 2 will be connected to VCC through a pull-up register. So this is known as a pull-up programming. So by this syntax, we have just replaced that 10K registers. Now let us again export binary. Then run simulation and let us check something is happening or not. See, switch is on, that's why LED is on. Now switch off, LED off. So it is working. Thank you for watching. Not forget to subscribe my channel and press the bell icon to get notification of my video.